code enforcement in historic buildings. However, since it was perceived as a lower level of safety by building officials, it was seldom used. In 1984, after this was recognized as a problem, Senate Bill 2321 made the use of the code mandatory for building departments to apply to historic buildings. The regulations of the CHBC have the same authority as any law, and so actually supersede the California Building Code and the local ordinances for qualified historical buildings. I want to emphasize that the CHBC is the first place to start when you're undertaking restoration, rehabilitation, repair, or reconstruction of a historic building. To write and interpret the code, the statute that originally enabled the CHBC.
Yeah, it's fine with it, Don. We can see it. It should give us
a... Sorry, Alan. Could you press *6 on the phone and re-enable your sound? Thank you.
Have you heard anything up to this point?
Yes, we're still hearing you. You sound good right now. Thank you.
Okay. So I'm sorry. Have you heard anything up to this point? Yes. Okay. Anyway, in order
yes,
to,
we have.
to write the code.
Yeah, I just had to mute. I had to mute the rest of the users. So you're good now. Okay.
The statute actually established the State Historical Building Safety Board, or the CHBC. The board can interpret the code for building owners or local or state jurisdictions, and it has the ability to hear appeals to decisions made by all code enforcement jurisdictions. The SHBSB is comprised of representatives from all relevant state agencies, from design professional organizations, building owners, building officials, and all other organizations that could be identified as having interest in historic buildings or in construction in general. So it's a well populated group and does not make knee-jerk reactions in terms of historic buildings and interpretation of the code. So what is a qualified historical building? This slide just represents the fact that the code covers a wide range of buildings. The actual definition is in the statute and in Chapter 2 of the CHBC. It's very broad and inclusive. It includes not only buildings on local, state, and national registers, but includes buildings that have been determined eligible for those registers, and even buildings that have been identified as historic only on local surveys or inventories. The CHBC is organized in a similar manner to the CBC, but it differs in that it's not a prescriptive code. It's really performance-based. So while it's tempting for, say, a structural engineer to jump to the structural chapter, the majority of the code provisions that actually apply to structural work and all other work reside in the administrative chapter, and that's the place you need to go first. The administration chapter establishes purpose and intent, and the intent of the code is basically to provide a reasonable level of safety for buildings that qualify as historic buildings. The purpose of the code, again, to provide solutions to preserve historic buildings while providing access and a reasonable level of safety. As a performance-based code, this provision states that enforcing agencies are required to accept any reasonable equivalent solution developed by an architect or an engineer. The administration chapter makes it clear that the CHBC is applicable to all issues regarding code compliance in historic buildings. Again, the first place to look for the applicable codes for historic buildings. And finally, it states that local and state enforcing agencies shall apply the provisions of the CHBC when it is selected for use by the building owner for all work on historic buildings. Some of the provisions that impact structural work on a historic building include the fact that repairs can be made in kind using historic methods and materials. that unsafe building and conditions can be remediated without bringing the rest of the building into compliance with the regular code. And that for any project involving a historic building, no triggers exist for additional work that might be required by regular code, regulation, or ordinance beyond the work originally undertaken. There is an exception for compliance with accessibility requirements, or if it is determined that a distinct hazard exists. And we do define distinct hazard in the code, and I want to point out that conditions that do not meet the requirements of current regular codes and ordinances do not of themselves constitute a distinct hazard. So finally, we get to Chapter 7. If it's determined that a structural upgrade is required by ordinance, like a local URM ordinance, or if a voluntary upgrade is desired and the engineer is looking for a compliance level that they can point to, we move to this chapter. But I want to point out that the projects we're going to be looking at in the rest of this presentation made very little use of this chapter. Most of the use of the CHBC was made from the administrative chapter and the provisions that allow the repair of the buildings, work to be accomplished without causing triggers. I do want to point out that in the intent section of this chapter, it does define basically the standard for structural retrofit or upgrade, or basically performance of the building as being the prevention of partial or total collapse, again, to reduce the overall threat of injury as a result from this collapse. I'm going to pass the baton on to Terry.
Thank you, Alan. So Alan's last slide, demonstrating the intent of the CHBC, is actually the perfect segue to the balance of the presentation, in which we will present examples that illustrate exactly how the CHBC can be used and has been used in assessing, repairing, and strengthening historic structures. It also is a segue to this particular slide, which I think provides a template of sorts as to the overall tone of this presentation. Different from what is done has been done oftentimes in the past. The CHBC allows us to elevate the idea of engineering with the goal of preservation to the same level of a hierarchy of priority as engineering for seismic safety. We all know that traditionally engineers in the issue of seismic safety have tended to govern a lot of work on historic buildings in California. Not that it necessarily should govern it, but that's how the profession has acted a lot over the years. The CHBC allows us to elevate engineering for preservation as a specific goal to an equivalent level of importance as engineering for seismic safety. So first example is a case study of Congregation Sherith, Israel, which I'm not going to read the entire slide to you, but this is a 1904 pre-1906 earthquake structure in San Francisco. It is a building that was essentially built. It's a jewel box. Almost its entire function is to house the sanctuary that you see in the lower left corner of the screen. That sanctuary takes up the vast majority of the interior space in this building. And as such, this building is very different structurally from many that are built today. And it needed to be handled in the work that was done to it. It needed to be handled in a manner that accommodated this peculiar use and this very, very unusual structure. The history of this building is that it was noticed under the San Francisco URM ordinance, and it was required by the city to be seismically assessed and upgraded if it was found to be deficient. There were two earlier seismic upgrade schemes that had been proposed by engineers over the years. Neither of them, the congregation chose not to proceed with either of those solutions. One of the schemes would have required concrete and metal deck diaphragms together with encapsulation of the entire historic exterior in shotcrete walls, which clearly was not a wise choice from the standpoint of preservation. The other scheme would also have required concrete and metal deck diaphragms, but in lieu of working on the outside of the building, would have required removal of much of the historic interior lath and plaster finishes, including all the mural painted plaster, or much of it, and replacement of the interior with shotcrete walls. This work really stemmed, I think, from a severe misunderstanding, or these proposals stem from a misunderstanding of what is allowed in the state of California by the historic building code. Both schemes would have destroyed rather than saved the historic elements that they really should have been designed to protect. You'll hear this is the next bullet point is a common theme within this presentation. Both schemes would have supplanted the existing archaic system rather than merely supplementing it. Engineers don't like to use brick masonry in the state of California, but they are allowed to, and there is no denying it that existing brick masonry walls have significant capacity, and in fact, in this particular structure, it was saved by relying on the capacity of the existing brick walls. Both these schemes fell into the trap of what I like to call as chasing your tail. By calling for concrete and metal deck diaphragms to be installed, they completely changed the way this historic building wanted to work. The engineers were trying to turn this building into a modern building, to behave like a modern one, and in doing so, that caused the brick masonry walls to become overstressed. The strengthening criteria for this project were essentially to comply with the San Francisco URM ordinance, comply with the CHBC, and to employ non-prescriptive performance-based engineering, which I will say at the outset does not automatically mean that the engineer should be running to ASCE 41 for guidance. ASCE 41 was really not developed with these types of buildings in mind, and it's really not the best resource. So the ultimate engineering solution for this building that did preserve both the interior and exterior was developed based on first principles, relied on the California Historic Building Code, did not require the use of any shear walls, braces, or frames to supplement the strength of the existing brick masonry, did not require the use of any expensive base isolation or damping systems, did not require any global foundation strengthening, and didn't reference either ASCE 31 or 41. As a general approach, again, the philosophy of the upgrade, of the strengthening of this building, was to identify the critical vulnerabilities in the existing structural system. And by critical vulnerabilities, I mean those that really matter. All buildings have vulnerabilities. When you're working on historic ones, the idea is not to remedy all of them, but to find the ones that are, if you're required to strengthen a building, that will lead to death of occupants or passersby, and to surgically mitigate those. We can find ways to surgically mitigate things. At the same time, we should be identifying the positive attributes of the existing structural system, not throwing the masonry out, the baby with the bathwater. The masonry works, but find surgical approaches to leverage it. The general approach, again, is to identify and prioritize the primary life-threatening systems. We normally begin these projects by using conceptual assessments. And with respect to this particular building, I'll show you a couple of examples. This on the left is a plan of the building. You can see that the masonry walls, it doesn't really come out so well at this scale, but the masonry walls, 3 of them are highly articulated and planned. They actually have, because of these articulations, out-to-out dimensions of roughly kind of through thickness dimensions, essentially of around 8 feet, which form structure within the structure. And conceptually, this is kind of what we have. 3 of the walls in the building have these substantial arch-like structures within them, and we can leverage those in the course of understanding how the building works and trying to make it work to satisfy ordinances. This building is also extraordinarily light. While it has a heavy slate roof, the entire top of the building is sheet metal clad. The interior of the building is steel framed, and of course, as I said, is mostly open because it's a big sanctuary. The steel framing is extremely light, and that lightness means that the seismic mass of this building really originates in the walls, not in the floor systems. We like to use extant damage to confirm behavior. This building, as I said, went through the 1906 earthquake, and it is a living museum. Most of the 1906 damage in it is still there and can be read like a book to tell us, to help us identify what the critical modes of behavior are in this building. This happens to be a plaster wall, that one of four that's shown in blue here, that supports the one wall in the building that is not articulated and planned. This wall stands out as being somewhat vulnerable. In addition, the piers, the Latin plaster finished piers in the drum all exhibited damage from the 1906 earthquake. The gable end walls as well. These are photographs of the gabled end walls of one of them, and we know that gabled end walls in these types of buildings are vulnerable. So this told us really a good deal about the vulnerability of the building. We also like to use historic data and benchmarking, which are critical ways in which to approach these buildings. There's a significant inventory of ground motion data, if you will. It's not instrumentation data that we develop today after when earthquakes occur, but there is data available that tells us about the distribution of shaking intensity around San Francisco in 1906. There are historical photographs available, one of which you see on the right, which shows Sherith, Israel being repaired after the 1906 earthquake. The Bancroft Library, for example, has written records of what the damage was in San Francisco, and this is one particular example of that record that talks about this particular synagogue and the damage that it experienced in 1906. We also like to use common sense on all our projects. And this is no exception. Everything shouldn't be coming out of a computer. We have to be careful to rely on computers that tell us certain things should have been damaged that weren't. We also like, in projects like this, it's very important to recognize that all extant structure has some capacity, and engineers' preferences to ignore certain capacity that's in a building really is not a wise choice when it comes to preservation. In general, it's important to keep in mind that preservation is about much more than just saving the pretty stuff. And this is really an admonition for the engineers who might be on this call. Historic structure has inherent value of its own. It has an original function, a historic function, and that function should be maintained where it can be maintained. There's no point in making the historic structure itself, the structural elements, turning them into museum pieces, making them obsolete by putting in concrete shear walls everywhere, and supplanting their function. It's also important to keep in mind that the simplest solution from the seismic safety standpoint is rarely the best solution for preservation. It, in fact, almost never is. Just a few little pieces of wisdom. We should be looking for means to convert, to leverage positive attributes of the system, to convert negatives into positives. We should be looking for the key to the lock, the most bang for your buck. In this particular building, the surgical solutions that actually left the building untouched from the standpoint of a viewer on both the inside and the outside of the building, we installed floor-to-wall ties that we found places for that could be installed without damaging finishes. Center cores were used to improve the integrity of the masonry walls, but not to improve their strength. Parapet bond beams were used to control crack propagation at the free edge of the wall, which is very important in masonry structures. Concrete pilasters were used on that one wall that's hidden from view here and really hidden from view from almost any angle. That's that one wall that's not articulated that I pointed out earlier. Foundation outriggers were used to improve the out-of-plane stability. In general, and a high-tech tension tie system was used in the gable to support the gable walls, and this is kind of a schematic of that. The steel tension tie system, just using steel rods, are shown in red, and nitinol superelastic wires extended to the gable end walls. The use of nitinol in North America on this project is, I think, its first use in North America. These schemes allowed us to save the structure, and today it looks just like it looked really before we started.
Okay.
I will now pass it to Gwen.
I'm going to talk a little bit about the Scribe Hacienda and the State Historical Building Safety Board, the BHBSB.
SHB.
SHBSB. I'm going to call it the board from now on. As Alan talked about, the board has a mandate to provide interpretations regarding the CHBC, to review proposed designs, materials, and methods, to hear appeals, and in the case of a state-owned building, where you have a state agency, if the building is proposed for demolition, the board is required to get involved at that point before any demolition happens, and that's in section 8104. Okay, this is called the Scribe Hacienda. It's a historic building in Sonoma County. It was built about 150 years ago as part of one of the first vineyards in the region. So it has tremendous historical significance in terms of the wine that's made in Sonoma County. It had been abandoned for years. However, it had been determined eligible for the National Register of Historic Places by Sonoma County. So therefore it is eligible for use of the CHBC. It was actually listed in Sonoma County's Register of Historic Places. The new owner, it was recently bought, the new owner wanted to restore it. The restoration costs were excessive. The design team originally hired wanted to bring the entire building up to current code. We were asked at a later point to assist with the use of the CHBC to help reduce the cost and scope and not bring the entire structure up to current code. In this case, the primary solution that we were able to give was protecting and reusing the existing basement walls. The basement walls have a soft lime-based mortar. They were in generally good condition. There were some cracks that needed to be repaired, but in all, for 150-year-old basement walls, they were in pretty good shape. And they actually calced out as okay using the presumptive minimums in the CHBC, which says that you can assume it has a certain capacity without doing any testing. It's a very low number. Just you go right to that provision and you can use, it turns out it's 9 pounds per square inch as the allowable shear in these walls. And these walls had withstood the test of time. There are two provisions in the CHBC. One is 8705.1, which talks about if you have a structural element that has been tested and has been doing well, you don't really have to worry about it. And there are also, because this structure has seen 3 significant earthquakes, including the 1906 earthquake and the most Napa earthquake, there are historical records that we can use. We can, again, Terry talked about benchmarking. It's the same thing. The building official was reluctant to allow the presumptive minimum of 9 psi. He wanted testing. And we could have done testing. However, that would have made disruptive to the interior, and it wasn't required by the CHBC. The building official also questioned whether you could actually use that 9 psi capacity to resist earthquake loads. And this is all covered in CHBC section 805.1, where it says if you use the presumptive minimum, no testing is required. So in this case, we went to the board and we asked them to issue a written opinion confirming that, 1, a presumptive minimum does not require any testing. That's the whole purpose of a presumptive minimum. It's a low value that doesn't require testing. And that you can use that shear capacity to resist earthquake loads. The building official's question was, well, it doesn't say you can use it to resist earthquake loads. So we wanted clarification that the building official could hang his hat on that says, yes, it obviously can be used to resist earthquake loads. And what we got back in fairly short order, they were quite helpful. The board wrote back and said, yes, you can use the 9 psi as a default without testing, and you can use that value to resist lateral loads, including earthquake loads. The request for testing was then withdrawn by the building official, and the CHBC helped keep the foundation work to a minimum level and helped keep the project within the financial reach of the owners so the project could actually go forward. Another case study, this is the Antelope Valley Indian Museum, and it deals with alterations and operational controls. Both topics, well, the operational controls isn't specifically covered in the CHBC, but it's part of using your judgment and broad discretion. The Antelope Valley Indian Museum is in Southern California in the Mojave Desert. It's a sprawling 1- and 2-story structure. It's historic. It was built by H. Arden Edwards in the 1920s, and it was completely not engineered. Mr. Edwards was a set designer in Hollywood, and it seems like he took whatever lumber was extra and brought it out to his homestead in the Mojave Desert and slowly built the structure over a decade or two. It has the absolute minimum of structural framing components possible. And he used it as a museum. It had no insulation, and in the Mojave Desert it gets quite hot and it gets quite cold. Those temperature swings, at some point the state acquired this structure and they acquired the museum collection within it, and they wanted to keep using it. And it's still known by its original name, the Antelope Valley Indian Museum. I'm referring to Native Americans. The large temperature swings were starting to adversely affect the collection of artifacts. The structure is very unique. It's built within a field of large boulders. Large boulders are actually incorporated into the interior architecture as well. That's John Lesak from Page and Turnbull, who helped with the project. Obviously, accessibility is a concern in something like this. It's hard to make, you can't really make that staircase accessible to wheelchairs, or there was a railing, but that was it. It's extremely tight. The interior of the museum is covered with artwork, so we can't really insulate on the inside. Most of the structure, when you look at the inside, you're also looking at the inside face of the outside. There's no stud cavities. There's very little opportunity to insulate. In this case, we could insulate on the exterior by bumping up the roof. Now this is reversible. It's not immediately noticeable when you go and look now, but we did add extra 2x8s that were tapered, as you can see here, and we put insulation between them and then put new sheathing and re-shingled the roof. The shingles were not historic to begin with. As I said earlier, the structure was quite light, and we ended up doubling the weight of the roof just with putting in 2x8s tapered at 2 feet on center and insulation. So the structure needed to be strengthened vertically and laterally, at least to some degree, so that we weren't making things worse. And although we added weight, the CHBC did not require us to bring every component up to current code requirements. We worked with the building official, who in this case is the Department of Parks and Recreation, to come up with a reasonable solution. In addition, we added operational controls. The CHBC allows you to use judgment. In this case, we could require that next time the building is re-shingled and they have to put a new roofing on it, that they shore it. In this case, we decided to design the roof for 12 pounds per square foot and move 20 to help reduce the impact of adding the weight. And the building official was okay with that. And that was built right into the drawings. So in this case study, the CHB allowed judgment and broad discretion on both the part of the engineer and the building official. And we ended up with a creative solution that was within the budget. If we weren't within the budget, the project was not going to happen. And we provided a reasonable level of safety. I'm going to turn the talk back over to Alan, who's going to talk about rear's loft.
Okay. This is a project that involved use of the CHBC and rehabilitation of a very deteriorated wood frame structure. The building was undergoing a change in use. It had originally been a shipyard building, and it was not clear entirely what it was going to be used for, but we knew the use would change. And the main use of the CHBC in this project was to make that change in use, do the repairs to the building without bringing the entire building up to code. This is called the Rigger's Loft. It's a World War II ship outfitting building that was constructed in Richmond, California in 1941. Built as part of Shipyard Number 3 by the Kaiser companies to construct victory ships right after the bombing of Pearl Harbor. It's one of only 6 of the original buildings that remain in the shipyard. The Riggers Loft housed a rigging, sheet metal shop, paint shops, all for outfitting the victory ships. The bulk of the building is wood frame structure. It's constructed of exposed posts and trusses with a wood stud wall infill. It had been all but abandoned since its use as a shipyard building. It was in a severe state of deterioration, not only the building envelope, walls and roofing, but the actual roof structure itself. The wood roof members were rotted out over a considerable portion of the building, and the roof had partially collapsed at about 3 locations due to water buildup from clogged drains. And the failure had been basically a failure of the bottom cord of the wood trusses, which were under-designed for loads, at least the way we design trusses nowadays. The paint shop, which is just this corner of the building, it is constructed differently. It has 4 8-inch thick concrete walls that actually form the perimeter of the shop, but with a wood roof as well. This held water so successfully that the entire wood roof collapsed. We had nothing left of the wood trusses of that roof. So the project originally called for repair of the deteriorated wood elements in kind, and basically bring the building up to just basically repair it to its original configuration. But the Port of Richmond decided partway through development working drawings to locate the Emergency Operations Center in the paint shop area, which is the area outlined by green. So we had to actually shift our focus from localized repair to a seismic upgrade to meet the requirements for an essential facility. I want to show you some things about this this model that's on screen right now. Kelly Kobe in our office was a structural engineer for the project. In order to understand how this structure would respond to the additional lateral loading that was required under the essential structural requirements, she created an analytical model here, and this is an isometric that's taken from that model. The analysis identified that the concrete box, which is the green walls of the paint shop here, were very stiff, and we decided we could take advantage of that. We added steel collectors in the roof along this line of the outside wall, and along this line of the outside wall here to connect the roof to that strong structure. We did find that there were crossing truss elements along the outside walls, along the center wall, and down the center of each one of the spaces, and those were very flexible, but still added a great deal of strength to the roof. At first, it appeared that steel frames might be required, especially in this area of the building that's remote from the steel box, the torsional forces. But we were able to identify one existing partition wall between the sheet metal shop and the welding shop that we decided we could use as a new wood shear wall. So the project itself, we repaired the trusses in kind, did not upgrade them in terms of their strength. We replaced all the deteriorated wood framing. You can see a mix of the existing framing, which is still whitewashed, and the new framing. This photo also shows the steel tube connector. Here's the riggers, the paint shop right here. This runs down the center wall of the building, and it connects the roof into the concrete walls of the paint shop. The use of those paint shop walls, which are over here in the corner, really put a huge demand on the roof, and so it was decided that we needed to actually put down a plywood diaphragm on the roof. We were concerned about doing it because the roof loads, the live loads on the roof, we actually outdid the Antelope Museum. We calculated those out as only being 7 pounds a square foot. And so what we did was we did add this weight of the plywood, but we also changed out the roofing from the original built-up roof to a single ply membrane. We were able to keep the weight of the roof pretty similar, or actually a little less. We did actually have to institute programmatic conditions, and those were basically that the roof could not be loaded for re-roofing at any one point. So all the loading was put off-site and roofed from there. This is the partition wall that we upgraded. The original siding was removed and it was resheathed. New foundation was put in, and micropiles were inserted at the foundation level. We did not sheathe the truss. We were comfortable that the truss could actually provide the shear transfer that was necessary, so we could leave that unsheathed. This is that wall with the siding replaced. We did supplement the original steel rod bracing with rods that went from truss to truss. This in order to prevent the trusses from twisting in a wind uplift condition. And finally, this is a shot of the interior of the building after the work was done. Pretty much still wide open, no visible changes to the structure. Passing it off to Terry now.
Thank you again, Alan. The CHBC provides all of us with alternatives for repair of earthquake damage that enable, again, are focused on preserving historic structures and enable us to accomplish repairs in manners that the CBC does not allow us. So this segment of the presentation is really to talk about what does the CHBC allow us to do in the way of earthquake damage repair using examples from the Napa earthquake. I'm just going to raise as kind of an archetypical example the Napa County Courthouse, which was built in 3 parts and 3 stages. We're going to talk for a second about the 1878 section of the building, which is the most historic part. This really is, what I would like everybody to do is to understand that what I'm going to show, I mean, I could have shown almost any historic masonry building that's been damaged in an earthquake anywhere in California over the last 100 years. Many masonry buildings in California experience the same kinds of damage, right? We experience cracking to the brick masonry. We experience oftentimes some brick fall starting from attic walls or parapet walls. So this is just an example of that. It's a convenient example to use. These photographs were taken short. This was a building that was actually strengthened in 1977. And I'm just going to show you 3 pictures to give you a sense of the type of damage I want to talk about. It doesn't really matter which building it's in. As you can see, there's fairly substantial cracking to the 2nd story brick masonry. We've experienced local brick fall here. We have some loosened ornamental sheet metal cornices And in one corner of the building, we have a fairly substantial amount of brick fall. So what really does the CHBC allow us to do here? Well, first, it's important to understand that the CHBC has provisions for repair. They have provisions for seismic strengthening. There is, by the way, no triggering of seismic strengthening anywhere in the CHBC. And they have provisions for reconstruction. These three things are different. Repair does not equal strengthening, which does not equal reconstruction. If we're on a repair project, we need to pay attention to the repair provisions. So let's identify what some of those are. You're going to see some repetition here because Alan already mentioned them, but now you're going to get them in context of a real problem. What do you, and with that problem being, what do you do when you have brick masonry damage to a historic structure? So this particular provision in the CHBC clearly allows in-kind repairs to be made with historic materials and historic methods of construction. First, by the way, I'm going to give you 4 slides that address what I would call relevant CHBC provisions. Then I will show you a few slides of potentially relevant provisions, and then a slide that deals with irrelevant provisions. So this is the second relevant provision that governs historic and archaic materials and clearly states that archaic materials and methods of construction may remain or be reinstalled or be installed with new materials of the same class to match existing conditions. Again, a clear statement that there is no intent in the code to trigger something, work that is not there, and change out of materials, substitution of new materials for older ones. This particular provision on reconstructed walls tells you very clearly that you can even infill existing walls where brick has fallen out. You can replace that brick in a manner similar to the construction of the original walls without conforming to the regular code. And finally, in the list of relevant provisions that I've chosen to put up here is a section on additional work that says that qualified historical buildings shall not be subject to additional work required by the regular code. In other words, we can rely completely on the provisions within the CHBC for structural repair, to govern structural repairs. Potentially relevant provisions include this one, which Alan also showed for unsafe buildings and properties. This section says work to remediate the buildings or properties need only address the correction of the unsafe conditions and it shall not be mandatory to bring the entire building into compliance with the regular code. I show in this next slide the analysis of this provision. The analysis is that we ask the question, do the earthquake-related unsafe conditions relate to locally loose or unstable brick masonry, as in the example that I showed? If the answer is yes, then remediation of the unsafe condition only requires removal or stabilization of the loose, unstable brick. There is no need to do work beyond that to effect repairs. This potentially relevant provision on the definition of life safety hazard says that conditions that do not meet the requirements of current regular codes and ordinances do not of themselves constitute a distinct hazard. A suggested analysis for this provision follows on this slide. We should be asking the question, can the following hazards that constitute life safety hazards be removed or stabilized? If the answer is yes, then we should be stabilizing them. That alleviates the life safety hazard with respect to that issue. The next question to be asked is, was the building evacuated for other reasons? Because one of the provisions, one of the statements in this provision addresses hazards to occupants. But if the building has been evacuated, then no occupants can be endangered, and there is no life safety hazard with respect to occupants. The last question is, can fencing be installed to prevent passersby from approaching? Because we are also obligated in assessing whether there is a distinct life safety hazard to assess the hazard with respect to passersby. If you can install fencing and that will prevent passersby from approaching, then the mitigation means is to install fencing. The last potentially relevant provision that I'll put up on the board here relates to the definition of imminent threat, and states that where an emergency is declared and the property is declared an imminent threat to life and safety, the state agency assessing such threat shall consult with the SHBSB. The analysis of this particular section is as follows. We ask the question, was the building declared an imminent threat by the authority having jurisdiction? It is not up to a practicing engineer to declare a building an imminent threat. It is up to the AHJ, and if it has not been so declared, there is no imminent threat according to the CHBC. The second point of analysis is that if there is a state agency involved in assessing the threat, then the CHBC does not allow demolition without first consulting with the SHBSB. A short list of irrelevant code provisions, and I could go on at length on this one, but just the short list is, if you're repairing a historic building, you do not go to the CBC substantial structural damage provisions and triggers. They are irrelevant. You do not go to the CBC terminology that pertains to things like dangerous building. That too is irrelevant. You do not go to the California Existing Building Code, Appendix Chapter A1, even though that chapter addresses hazard mitigation for existing masonry walls. That chapter is irrelevant. You do not go to the CHBC Chapter 7, the structural chapter, unless an upgrade is triggered by local ordinance. What governs are the provisions that I showed early on. Segueing to the last part of this example, I wanted to discuss for just a moment the tendency of society and the profession to judge the adequacy of historic buildings based solely on the damage that these buildings experience in earthquakes. We should not be doing that. We need to assess the adequacy of buildings considering both the damage they experienced and the intensity of ground shaking to which the building was experienced. A historic structure that has earthquake damage is not automatically seismically inadequate. As an example, which I'm not going to read, but recognize that in the upper left, we have a building that experienced minor to moderate shaking and was severely damaged versus a building that experienced moderate to severe shaking and was severely damaged. These two buildings are not equal. We should not be treating them equally. To look quickly at what happened in Napa and bring this example home, this is a shake map from the Napa earthquake. As you can see, the strongly shaken region was pretty well confined to a narrow band. This is a close-up of that region, identifying 3 instruments that recorded the intensity of ground shaking. The center one is the downtown Napa instrument. Zooming in on a map of downtown Napa, with the color of the shake map superimposed on the map, I'm showing the area that this is downtown. This little dot is where the Napa instrument is. Zooming in a little bit more closely, here's the Napa courthouse. It's all of a block and a half away from this instrument, making this instrument a very good representation of the ground shaking that the courthouse experienced. This was a living laboratory that allows us actually to see how good is this building, how well did it function in an earthquake of this particular intensity. Again, here's just a little better close-up. So now to bring this home, this is a plot that shows in orange, if one were to look at the CHBC and the voluntary strengthening criteria that exist in Chapter 7, you would end up plotting what is shown here as the orange line. This is a representation of the force level to which a building should be upgraded if you're using the CHBC provisions for voluntary strengthening. The blue line represents the intensity, the force level, if you will, that buildings in downtown Napa experienced during the Napa earthquake. As you can see, the blue line exceeds the orange line, meaning that buildings in downtown Napa already experienced the event to which they would have to be strengthened if you were using the voluntary strengthening criteria in Chapter 7. To read this plot, recognize that most of the historic masonry buildings in Napa fall into this particular range, where the blue line clearly exceeds the orange line. There are other, this particular plot is for one direction of motion, this plot is for the other direction of motion, and this merge plot is the geomean, essentially showing that the blue line is equivalent to the orange line. What that means essentially is not only is there no CHB mandate to upgrade a building under these circumstances, because there is no applicable ordinance, there just is simply no requirement to upgrade it. It also doesn't make a whole lot of sense to upgrade a building like this because it demonstrated that it already can resist the voluntary seismic forces without substantial collapse. On to the next piece of the presentation, which again I have, which is designed to demonstrate to all of you folks that the CHBC allows us tremendous latitude and allows us to do things that would be unachievable if we just went to the regular code. In this segment of the presentation, we're going to be talking about hollow clay tile. The problem statement is this. We know that hollow clay tile presents potential falling hazards during earthquakes, both to occupants of buildings and to passersby, but we also know that oftentimes in buildings, the hollow clay tile is often a backing for character defining features. The problem statement includes the fact that many design professionals often assume that because hollow clay tile is risky, that it requires removal, and they specify its removal, which oftentimes severely damages historic integrity. But the CHBC does not require HCT to be removed. It also does not preclude stabilization of HCT if the engineer chooses instead to stabilize it. And if we elevate engineering for preservation to the same level as engineering for seismic safety, the choice should always be to stabilize it if it can be stabilized. Some codes, like the San Francisco Building Code, for historic buildings have required that HCT be mitigated where it affects egress. But beyond that mitigation, there are no requirements. And where there is no requirement to mitigate HCT outside of egress ways. It's important to note that mitigation does not equal removal, and there are numerous ways to mitigate falling hazards from HCT, which I will demonstrate in the balance of this segment of presentation by way of using a recent project, the Hibernia Bank building in San Francisco, whose seismic strengthening is almost completed. But we're not going to be talking about the seismic strengthening. We're only going to be talking about the hollow clay tile solutions that were used on this project. I'll be talking about three circumstances. This wall identified as area 1, this header identified as area 2, and this doorway identified as area 3. Area 1 is this 2-white hollow clay tile wall that runs the length of what's called the customer service waiting area. Here's another view of it. It was going to become a path of an exit way because this window is going to be converted to a new exit. Amongst the many problems is through these doors are very sensitive historic areas. These are offices. This is a photograph of one of the offices. We did not wish to really damage either the finishes in this room or the hollow clay tile supporting those finishes. In addition, the problem includes the fact that we have decorative metal door frames whose width requires that the existing wall be maintained at the same width that it is today, the existing hollow clay tile wall. We have a marble base that would have to be moved and altered if we altered the width of that wall, the thickness of that wall, and also we have a marble floor tile that would be severely disrupted if we thickened that wall. So what was done was a method of stabilizing the HCT was developed using steel studs and essentially anchors into the hollow clay tile. This is a view of that work being done. These are temporary wood studs, but here are some of the new cold form steel studs. Here's an image of the hollow clay tile with an HCT anchor through it. This was done as a test. There was blocking installed to maintain the existing thickness of the wall as a spacer. This is a view of the cold form steel wall the stud wall after it's been completely assembled and anchored to this to what is now a single width of hollow clay tile. This was all done without causing any cracks to the plaster on the other side. This wall was dismantled surgically, and it worked. We did that entire wall in this manner that you saw. In fact, in part of this wall, we actually installed a cold form steel shear wall, which I understand is probably the first one in San Francisco. This is a view of this area today, and the character of it is exactly as it was before. Area 2, in this view, if you looked, just turned around 180 degrees, this is that single white hollow clay tile wall that I'm using for the next example. This dotted line represents the approximate line of a stairway in the backside, which I'll show you in a minute. This is an existing brick masonry wall behind these finishes, an existing concrete wall in this elevator shaft. This is a doorway to an elevator. This is that stairwell. This is the single, where the cursor is, and the area blocked out in red is that single white wall. You can see why we didn't really want to damage that wall. We have lovely stone wainscoting. Details were developed here in which we put wire mesh on top of this wall, anchored that wire mesh into the hollow clay tile with toggle bolts, and anchored the wire mesh both to the brick wall on one end and to the concrete wall on the other end. The third example is of this doorway on the second floor that I mentioned, where this is all single white hollow clay tile surrounding this, and this door surround, which is part of the egress from the second floor. When you go into the attic above that second floor, you can see the tops of that hollow clay tile wall project into the second floor, into the attic space. And this allowed us essentially to just drop reinforcing steel or threaded rods down through those cells and to grout that material in place to stabilize those walls. Now I will pass the baton to Gwen. Thank you, Terry.
This last example is the James A. Garfield High School, and we're going to show you how the CHBC deals with fire repairs in this case. As we've talked about earlier, the CHBC can dramatically limit the amount of upgrades that are triggered as part of a repair. This is a picture of the Garfield High School, and this is a historic photo of the interior of the auditorium. And it's got great finishes, and many, many people graduated from here. But in 2007, there was a big fire. The fire was extremely damaging in the area of the auditorium. The steel trusses buckled. The roof diaphragm was pretty much destroyed and fell on the seats. The walls were fairly intact. Some of them were maybe a little bit leaning, but most of the structure was actually okay, other than the complete loss of the roof of the auditorium. So the first question you have to ask is, well, is it historic? There was a cursory study prior to the fire, but after the fire, the school was subjected to much greater scrutiny, and it was found to be culturally significant by the school district's own consultant. And it had the reasons were it had historical and cultural uses. Generations of Hispanic Americans had gone through this high school, and the pre-fire auditorium architecture was also still historic. The front building had actually been modified in the 1950s as a result of legislation requiring upgrade of the building. But the pre-fire auditorium, the architecture was still largely intact, and so that portion was historic due to architecture. The other portions were, and the auditorium, were historic due to the cultural significance of the school. So the answer is yes. The school district actually never designated the building as historic, but it was found to be eligible by the school district's consultant. Now in California, we also have the DSA, the Division of State Architect. They have jurisdiction over schools. The DSA is legally required to accept the use of the CHBC for qualified historic buildings, and that's even for schools. In this case, DSA does publish, or has published in the past, guidelines and criteria for a whole bunch of things about schools. In this case, they have provisions relating to historic schools and buildings that are historic where schools are. And they encourage the use of the CHBC because they're legally required to. They recognize that the strict use of the regular code may create problems, and so they allow the use of the CHBC because it provides alternatives that allow the historic characteristics to be retained, and you still try to achieve the same performance as the regular code. In this case, the school district wasn't quite clear what to do, so they reached out to the board, the CHBC board, to ask their opinion regarding certain code issues. In this case, the board's response came back, yes, the school district itself may designate the building by themselves. The school district is basically the entity that can designate it as historic. Alternately, if the district isn't comfortable doing that themselves, they can ask the DSA to decide whether it's historic. They could submit the school district's historic structure report, thank you, Alan, and submit it and give it to the DSA, and then the DSA can make the call. Interestingly, one of the questions asked was, well, if we decide it's not historic, if the school district says we don't want it to be historic, then does that mean it's no longer historic? And that's not the way it works. The district doesn't have to declare it to be historic, but it doesn't eliminate the fact that it is historic. It doesn't say, well, then it has no architecture, cultural, or historical significance because we didn't want to use the CHBC. It still is historic, and you can still use it. It's voluntary. In this case, CHBC has certain sections that Terry went over, sections that say no additional work beyond that needed to repair the building is required. Repairs may be made in kind with historical materials and methods, and archaic materials and methods of construction may remain or be reinstalled. In other words, the CHBC allows you to put it back the way it was. That's the whole purpose of these repair provisions. In this case, because it's a school, DSA has other rules, and both the CHBC and DSA rules allow the building to be put back to a pre-fire condition after the damage. Accessibility is a bit trickier. It does not receive a waiver like structural issues, but the CHBC does provide alternative provisions. Those provisions are intended to help preserve the character-defining features and provide reasonable alternatives to the strict requirements in the regular building code. And this is taken from the DSA. They specifically mention in this case, they refer to the SHBC, the State Historical Building Code. That's another abbreviation for the CHBC, California Historical Building Code. In this case, we did need to add wheelchair accessible seating, and we did need to add a wheelchair accessible ramp. We added the minimum required seats. What the CHBC allowed was to targeted location of those seats to avoid loss of as many seats as possible. In this case, unfortunately, the district decided that they wanted a newer and larger building, and they ended up just demolishing this historic structure. It took quite a bit of effort to get down. It was actually much more robust than the school district anticipated. So the lesson of this case study is that the CHBC cannot protect against an owner electing to destroy their building, a private owner. But for those who are willing, it can eliminate some upgrade triggers and soften others. And those upgrade triggers are generally structural in nature, not accessibility. I'm going to turn it one last time back to Terry, who's going to finish up with our conclusion.
Just a few closing comments about the thrust of the presentation and about this notion, the balance between preservation and safety. I think we all know, we've all seen projects, historic buildings that have not been saved from the wrecking ball because of perceptions that they require, that there was some requirement that for major costly interventions that made saving those structures infeasible. I think we also probably have all seen projects on historic buildings that make us grimace because the extent of the work that was done to them caused a lot of damage, and much more damage than was probably necessary. One of the themes, if you take anything home from this presentation, it should be that the CHBC, when properly utilized, allows us to preserve historic structures in a manner that the regular code does not allow us to do. One of the problems traditionally in the state of California has been, well, I show it here diagrammatically below the red line, where the concept of engineering for preservation plays second fiddle to engineering for seismic safety. Seismic safety is oftentimes thrown on the table as the trump card that trumps everything else. If we use the historic building code properly, engineering for seismic safety is no longer a trump card. It needs to be considered an equal of the goal of preservation. It's important to understand, and I've said it many, many times to myself and to my colleagues, that preservation goals should not be subordinate to seismic safety goals. The engineering needs to have both preservation and seismic safety goals firmly in mind and at equal levels of importance. We all know there are potential safety issues with historic structures. Let's identify what the real ones are and play the safety card where it's absolutely necessary, but not in situations where it's going to turn saving historic structures infeasible. It doesn't make sense in that case. We should be trying to save historic structures and only invoking the safety card when it's absolutely critical. The proven approach for engineering and preservation, and proven approach involving engineering for preservation and seismic safety is laid out on this slide. And invoking steps like this is permissible in accordance with the CHBC. We should be, in all cases, fairly assessing the seismic resistance of the non-conforming historic structure. We should not be running instantly to ASCE 41 and assuming that that provides us a fair assessment. In most instances, ASCE 41 does not provide a fair assessment of the strength of a non-conforming historic structure. We should be creating and enforcing a hierarchy of equals between the seismic, structural, and preservation goals, looking in all instances to minimize impact to historic finishes. You know, there can be some very, very clever seismic interventions that require, for example, the installation of just small bolts in 100 places. But if getting to those 100 places disrupts the historic finishes in 100 places, then that's not such a clever solution from the preservation standpoint. We need to be thinking about solutions that work both from the structural standpoint and support the goals of preservation. One of my pet issues, as I've mentioned before, is that historic structure is itself something worth saving, something worth preserving, and something worth preserving in an active state. We should not be looking to turn historic structural elements into museum pieces that are not performing functions going forward. We should always be implementing beyond code thinking to avoid destroying a structure's historic value in the course of saving it, as could well have been done in the example of Sherith, Israel. In that particular example, the congregation was very likely to have abandoned the building if they were going to have to follow through on the proposals that had been presented to them earlier. We should always remain vigilant and resist the temptation to turn a historic building into one that behaves like a modern structure. It's actually very difficult to do that in many instances. The behavior modes, say, of a building like Sherith, Israel, are vastly different from a modern type structure. largely because in Sherith, Israel, 90% of the seismic mass of the building is tied up in the building walls. The seismic mass does not really originate in the floor slabs like it does in most modern buildings. So we need to be looking to preserve and leverage the original beneficial structural characteristics of the buildings. As a final note, and to remind the audience, assessment of this in the instances when we are looking to repair buildings after earthquakes, historic buildings after earthquakes, the seismic competence of the building really can only be made in consideration of the earthquake intensity that it has experienced. A structure that was moderately damaged in a low-intensity event surely is raising its hand and telling us all that that is a potentially problematic structure, and it should be looked at more closely. Alternatively, a structure that was moderately damaged, that was only moderately damaged in a strong intensity event, is actually telling you that it's a pretty good structure, no matter that it was damaged. Buildings get damaged in earthquakes. We need to understand that they get damaged, but that doesn't mean that we need to have a knee-jerk reaction to structurally upgrade every building that was damaged. So that's it for the talk. Thank you all for your attendance, and now I think we will answer questions. Jonathan, if you can help tell us if any have.
Sure, and thank you all for wonderful presentation. You covered some great case examples, and I'm going to turn it over to the audience now and ask that you please let us know if you're interested in asking a question. You can just type it in the chat box, or you can click on the raise hand symbol if you want to speak up with your own voice and ask the question in person. If you're on the phone, again, you would press *6, and that enables your sound on your phone, and that should allow you to ask the question in person as well. I currently don't see any questions in the chat box, but I did have a question from somebody asking if the slides are available in a PDF format, and I uploaded it to our website and it's available, and I pasted the link into the chat box. I can also email it out to everybody after this presentation concludes. So if you have any questions, please do ask them in the chat box right now.
This is Jay Salazar from the city of Vacaville. Can you hear me?
Yes, loud and clear.
Yes, thank you for, I got the PDF and we've been following along via the PDF because we've been unable to use the Adobe Acrobat. Well, I had a question regarding the Garfield School Auditorium situation. I think there was a slide that said something along the lines that the historic building code doesn't prevent a building owner from demolishing their building, which makes sense to me. But would the fact that it was if it's DSA regulated, even though it's a school district, does that make it in effect a state building that would have been needed to go to the historic board for review?
We don't think so. That provision actually applies to state-owned buildings and possibly state-funded projects.
Okay.
There is, I talked about two statutes that were done. The one that started actually enabled the CHBC, and then the one that made it mandatory for use by building officials when chosen by a building owner. There was a third statute that came out of a lawsuit that states that the state has to consult the CHBC, the board, if they are undertaking a project affecting a historic building, to make sure that they are making full use of the CHBC. And in addition, as Terry stated, if they're planning on demolishing a building, they have to consult the board to make sure that's necessary. But it only applies to state-owned buildings or state-funded projects.
And that's a great question, by the way.
Yeah, thank you. That would help me understand, because school districts are sort of an arm of the state in a kind of weird way. That's why I wanted some clarification. Thank you.
Yeah, there may be a legal question here that I'm not aware of.
Okay, great question. We still have the chat box up if anybody'd like to type it in. And again, if you're on the phone, you can just press *6. Maybe while we're waiting, I'll ask my own question of the panel. And I'm wondering what your experience has been with building officials. Do they often need to be made aware of some of the provisions in the CHBC? Do they understand it pretty well? What advice do you have for sort of explaining that?
I'll take that one. In general, a lot of building officials don't know it exists. You have to bring it to their attention. It helps to flag it early and say, hey, we're going to be using the CHBC. We're allowed to. You may not know about it, so we should talk about it. There does need to be more education about the CHBC so that people know, hey, this is a resource not only that people can use voluntarily, but sometimes, trumps a lot of triggers. And that can be difficult to get around, get into someone's head. Hey, it's great that the CBC has triggers, but this isn't a CBC building. It's a CHBC building because it's historic.
Yeah, John, I'll just mention, it's interesting, on the Sherith Israel project, as I said, we did use the CHBC to help guide the structural interventions that were made in response to the San Francisco URM ordinance. The building department of the city of San Francisco actually told us that while prior design professionals had used the CHBC on projects, no one had ever used it to justify the level of structural intervention that was being done. So it's been used for kind of the architectural aspects in San Francisco up until that point, but not really the structural ones, which was somewhat shocking to us. But given it really illustrates kind of exactly what Gwen said. If in a jurisdiction like San Francisco, the building department was really unaware of the way the CHBC can be used, this is a significant problem in the state, I would think.
Well, in the state in general, you're going to find the various different departments, building departments, treat the CHBC very differently. While most of the major building departments know that it exists, there is usually a question of application. And you have to understand that the building official is never going to come forward and tell you, oh, you don't have to do that, you can use the CHBC. It always has to be generated by the building owner or by the professionals that are hired by the building owner, and they have to understand it well enough to clearly describe how they're using it to the building official. It's really the responsibility of the building owner and the professionals hired by the building owner to establish the use of the CHBC.
Well, and I would suggest that there's maybe a role here for planning departments to even kind of raise that issue when projects come in the door with respect to planning, that planning departments can begin the dialogue by saying, hey, are you guys using the CHBC for structural aspects? Because whether you do or not has tremendous impact, tremendous outfall on the level of disruption to the building.
Full answer, and thank each of you for responding. I don't see any additional questions come in, so I'm going to wait another 30 seconds or so to see if anything else arrives. So please, this is your last chance.
This is Jay Salazar.
Oh yes, Jay.
Again, I do have an additional question regarding this interesting item that you did point out. By the way, I'm a building official, and I'm trying to learn a little bit more about this. So. You pointed out in one of your earlier slides about this idea of if something is eligible for a listing, which is actually something quite new to me. The way that I was been trained on the historic building code all these years is, hey, it's got to be on a list someplace. But I remember one of you, or many of you throughout your presentation, said, no, it just needs to be determined eligible. And my question related to that then is it as simple as having someone with some sort of historic background do a survey of a parcel and then having them write in a report, yeah, this could be eligible? Is that enough to make it a qualified historical building?
It may be enough for the city of Vacaville to decide that, the consultants or whoever it was that did the report, that what they are showing is valid, and the city itself can decide that based on that the building is historic. The wording that was used, determined eligible, is a little more specific than that. It applies to a number of different determinations, sometimes determinations made by the State Office of Historic Preservation. Sometimes if you are doing a survey and you're using the standard state Department of Parks and Recreation forms to do that survey, and that survey is filed with the state, the judgment of the person who has completed the survey on the form, which is usually in the form of a National Register code, saying that this appears to be eligible for the National Register, that in itself, it can be considered determined eligible. So there are some technicalities to it. Determined is different than we think it's eligible.
Right, and that's what I was trying to get at, is to try to figure out, is it, so as a local, does the local jurisdiction, though, does its legislative body, is there a requirement that the legislative body have to take some action? Or is it enough for somebody to submit something to, like the city of Vacaville, to say, here's our report, we think this is eligible? Yeah.
I'm not going to capture every situation here, but it's not necessarily required that the local jurisdiction make a judgment. For instance,
okay, good.
If somebody wrote a nomination, this has happened in the past, to the National Register for a building, and submitted that to the state. The state's going to do is going to actually do two things. One is they're going to read the nomination, and they're going to make a determination whether it appears to be eligible for the National Register. Number two, they're going to ask the building owner, who might not be the same person that did the nomination, do you want this placed on the National Register? Mm-hmm. It could well be that it's determined eligible, but the owner doesn't want it placed on the National Register. So you are left with a determination of eligibility without the actual listing on the register. There's another. Okay. Go ahead.
Well, then with that said, that's a good segue, because that's what I'm trying to get at. Then let's just say we think it's eligible based on all this data. The owner doesn't necessarily want it to be on a register, but thinks it's eligible. Could I then, as a building official, look at the historic building code and say, okay, well then you still only need to do the things, if you want to do something to your structure, that are in the historic building code?
Yeah, absolutely.
That's what I'm trying to understand.
Because actually, in the end, it's really the building department that's interpreting all of these determinations of eligibility, and we have even seen situations where the building department has gone to the planning department. Planning department says, yes, we think this is a historic building, and that was enough for the building department to accept the use of the CHBC.
Got it. Okay.
Another great question, Jay. That was great.
Thank you.
Okay, and we have another question that came in through the chat box. The question is, the term applicable ordinance, in quotes, was used several times. To what is this referring?
I'm not sure I remember what it was used. Can they be more specific about where applicable ordinance was used?
Is it referring to the trigger? I don't know.
I'm going to try and answer that unless we get a clarification. I mean, I think we're really just talking about if there is an ordinance that requires structural strengthening of a historic building, such as the URM ordinance,
or the soft story ordinance,
or the soft story ordinance, or something else. Yeah. Those ordinances will push you into Chapter 7 of the CHBC, but
if you had an ordinance that, like San Francisco, with specific limits on damage and then triggers and when things get upgraded, that wouldn't be an applicable ordinance. It's
correct.
Okay.
I don't know if we answered that. We're not sure if that answers the question or not.
Right, and I'm not seeing anything as a follow-up. So this is the last chance for questions. It's now 1:30, so we only have time for one more question if there is one. I'll wait about 30 seconds or so here to see if anybody starts typing something in. If not, what I would like to ask people is to complete our evaluation. This allows us to improve our programs and address things that you'd like addressed in future programs. So with that being said, I don't see any questions coming in, and I'm going to turn it over to our evaluation page. Special thanks to each of our speakers, and wanted to encourage each of you to attend our webinar next Wednesday, which will also look at the CHBC, but will look at the Broadway Corridor reuse guidelines as a specific case example. You'll find registration information on our website at californiapreservation.org on the left-hand side under webinars. I encourage you, if you're a city, to join us as a city member, or please consider signing up for a subscription, because we have about 24 programs a year, and this is just one of them, actually the third of the year. So with that being said, thank you very much to our speakers, and please do complete the form on the left-hand side of the screen. I will send out the PDF to everybody later via email if you haven't received it already. And in order to complete the survey on the left-hand side, what you'll need to do is click the Submit Response button at the top of the page to make sure that your answers are recorded. In the chat box below the multiple choice evaluation, please just type in any comments you have about this program or any suggestions for future programs. Thanks again for your time, and CPF truly appreciates your support, your membership, and volunteer time that the speakers have put in to present this program. Thanks again, everybody, and have a wonderful day.
Thanks, John.
Thank us all.